It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Farming Doing Nice Coffee.
Hi guys, this video today is going to be all about half equations. Okay, so half equations are really useful in chemistry, particularly when we're looking at electrochemistry or redox reactions. Okay, so when we're looking at any sort of power generation that involves spontaneous reactions, okay, where we're generating electricity, we're going to be using half equations because it involves the flow of electrons. If we're looking at doing any sort of electrolysis, so refining of metals, purification of metals, production of metals, that's going to involve half equations as well. So it's a really key skill to be able to quickly identify and balance half equations. Now, as the name suggests, half equations are half of a normal equation. So what you normally have is two half equations you then add together at the end. So I'll show you one example of that right at the end. Okay. But what you'll see in half equations that you don't normally see in a normal equation is electrons. And that's because in a normal equation, the electrons cancel out, okay? And so you don't see them. But in a half equation, you will see where they are, either on the left-hand side or the right-hand side. So what I'm going to do first is go through the 4 rules that you need if you want to be able to successfully write or balance half equations. So the first one that you need to know is that you balance any atoms that are not hydrogen or oxygen. Generally in a half equation you only have one other thing. It might be a metal, it might be a carbon, it might be nitrogen, something like that. Just make sure that they are balanced exactly like you would a normal equation. Then what you do is balance your oxygens with water molecules. So work out how many oxygens you've got on both sides, which one you're missing more oxygen of, and add water in to balance that out. Then balance up your hydrogens with H+. Now normally the redox equations we're going to be doing, so the half equations we're going to be doing will be under acidic conditions. Very occasionally you might have an alkaline condition, so instead of balancing with H+, you balance with OH-. So I'll show you one example of that, but it's pretty rare. And then the final one is you're balancing your charge with electrons. And so you need to be able to work out the overall charge on each side. And you can only add in negative charge, so you can only bring the number down. And I'll explain what that means in a minute. So I'm going to start off with a pretty straightforward half equation, okay? And I'm going to actually show one that even lets you skip this first step. So what I'm going to do is the half equation where we've got hydrogen peroxide, and this is a really strong oxidizing agent because it releases oxygen in solution when it decomposes. So what we have is hydrogen peroxide forming oxygen. Now this is what's called a redox pair. So we have one thing here, one reactant, this is the product of it, okay? And this is half of the equation that we're looking at. So what we're going to do firstly is we don't need to balance any atoms that aren't hydrogens or oxygens because we've only got hydrogen and oxygen in here. So now we need to balance our oxygen with H2O. So again, we've got 2 oxygens here, 2 oxygens here, so that's balanced, okay? Next step, balance your hydrogens with H+. So over here we've got 2 hydrogens. So we need 2 hydrogens on the right-hand side. So we're going to put in 2H+ on that side to balance it out. Okay. Then the final step is balance your charge with electrons. Well, overall on this side, we've got no charge on the hydrogen peroxide. So the charge over here is 0. On this side here, we've got no charge on the oxygen, 2 lots of 1+. So overall the charge there is +2. Okay. Now, to balance out our charge, we can only add in electrons which are negative. So remember what it says, we can only bring the number down. So we can only make a -2 go down to 0. So the way we do that is we add in 2 electrons. Okay? Adding in the 2 electrons there allows that to go down to a 0 charge, which balances out our 2 sides. So our half equation is H2O2 forms O2 plus 2H plus 2E minus. Alright, and that's an example of a half equation. Now, if you looked at some of the information about redox and what redox is, okay, you'll know that if you use oil rig, oxidation is a loss of electrons, reduction is a gain of electrons. So if the electrons are over here on the right-hand side, that means they're being lost from the hydrogen peroxide. So this is an oxidation half equation, okay, because we're losing electrons over on this side. Okay, so you can start to combine a couple of these together. Okay, so next one I'm going to show you will be a little bit more complicated. So we're going to do the hypochlorite ion, ClO-, and the redox pair of that is it goes to the chlorine ion, Cl-. Okay, so first step, balance any atoms that are not hydrogens or oxygens. There's one chlorine here, there's one chlorine here. So that's fine, we don't need to do anything. Balance your oxygens with water. So here we've got one oxygen, okay? So we need to add one H2O on this side, okay? Next step, balance your hydrogens with H+. Two hydrogens here, so we need 2H+ on this side, okay? This will become pretty much second nature to you as we go through it, and it's usually the last step that people find a little bit more tricky, so it pays to just take a little bit of time to make sure you understand this. So here our chlorine is -1, we've got two lots of hydrogen, which is +2. So overall on this side our charge is +1. Over here on this side we've got a chlorine with a -1 charge, and the water is 0. So over here our charge is -1. So we've got +1 on this side, -1 on this side. So what we want to do is bring the number down to +1, so it gets to -1. So what needs to happen there is we need to add 2 electrons in, and there's our balanced half equation. Okay, go on and do another one. So let's bring it up a little bit more. So now we're going to go to, make sure I've got enough room to be able to do this. All right, manganese, it's MnO4, so permanganate, I should say, sorry, which is MnO4 minus, all right, with a -1 charge. The redox pair of that is it goes to Mn2+, the manganese ion. Okay. Now this is quite common for us to use in titrations. Okay. Permanganate's a beautiful deep magenta or purple colour. Okay. And the permanganate ion, Mn2+, is colourless. So we get a nice colour change of purple to colourless when we're doing this in half equations. Alright, but in terms of redox half equation, alright, balance the atoms that are not hydrogens or oxygens, one manganese, so that's already done. Balance your oxygens with H2O. Well, we've got 4 oxygens here, so we need 4 H2O on that side. Okay. Next step is to balance up your hydrogens. So we've got 4 lots of 2 is 8 hydrogens that we need on this side. Alright, and then we get to the final step, which is around balancing up with our electrons. So I'll get some new pens before the next video. Alright, so what we want to do is work out a charge. We've got -1 there, we've got +8 there, so overall that gives us +7. On this side our charge is +2 + 0, which equals +2. Alright, so what we want to do is try and get our charge to go from +7 to +2. We can only bring the number down, so we need to add in 5 electrons on this side. Okay. Now, this is an example of a reduction because we're gaining electrons. They're on the left-hand side, so we're gaining them. So this is an example of reduction. So manganese is an oxidizing agent. Again, have a look at that redox video if you haven't looked at that one yet. So, last one I'm going to leave you with, and this is one for you to do on your own, okay, is if you can do this one, then you'll be able to do any of the ones that we need to do in Year 12 chemistry. So I'm going to give you the dichromate ion, which is Cr2O7 2-, and it goes to the chromium ion, Cr3+. So again, this is one we like to use because we get a nice colour change happening. Dichromate, Cr072- is orange. Chromium ions are green, so we get an orange to green colour change. So I want you to go through, try and balance that up, okay? And if you wait right to the end of the video, I'll put up the half equation there for you to be able to see if you got it right or not. So that's how we go through and we balance our half equations. I did say that I would just talk about doing one under alkaline conditions, so I'll just show that quickly for you now before we finish off. So if I want to do one under alkaline conditions, it's a little bit more complex. So like I said, I'm just going to go through one to show you this, and it really is around this step. So you're actually going to do this firstly, okay, and then you're going to come back to step 3 and look at adding in OH minus. Okay. So the one I'm going to show you is this one here, SO4 2- going to SO2. Okay. So if we follow through our steps here, okay, you balance out the atoms, so 1 sulfur, that's fine. Balance out your oxygens with water, so we need 2 H2O on this side, okay. Balance out then our hydrogens with H+. Now I know we're doing it in the alkaline, but we still do the same steps first. So there's 4 there, so we need 4 H+ here. And to balance out our charge, we need 2 electrons. So if that's how we were doing it under acidic conditions, that would be our final answer. However, we're doing it under alkaline conditions. So we don't want H+, we want OH-. So the question is, how do we get rid of the H+? Well, it's actually reasonably straightforward in terms of all you got to do is add in the same amount of hydroxide ions as you do H+. So we want to actually have 4 lots of hydroxide ions on this side here. Okay, so we've got 4 H+, so we're going to have 4 OH-. However, what you add to one side, you must also add to the other side, obviously. It's like a maths equation. So there's going to be 4 hydroxide ions over on this side as well. Okay. Now, what's going to happen is that this H+ here, and I'm really sorry about the pen, okay, the 4H+ here and the 4OH-, alright, this is just an acid-base reaction. When these react, they're going to create 4 lots of water. Okay, so it's going to create 4H2O on this side. Okay, now what happens is that we've already got 2 H2O on this side. So what happens is they're going to start to cancel out. Okay, and overall, what we're going to have in the reaction is SO4 2-, now with only 2 H2O, because we've cancelled 2 of them out and 2 electrons. Alright, so we've just changed it slightly, giving us SO2. We've lost those water because we cancelled them out, but now plus 4 hydroxide ions. Okay, so this is now the half equation done under alkaline conditions. So what you do is you just get rid of the H+ by adding in the same amount of hydroxide ions. Okay, and that way you then get your equation done under alkaline conditions. Like I said, it's pretty rare. All right, if you didn't quite follow through this, just go back and have a look at it. Hopefully it makes sense, but we don't have to do it too often. Now, the last thing I spoke about was how we actually then combine our half equations together to actually make our full equation again. So I'm going to show you that process because that will show you then how we therefore don't have electrons normally in an equation that you've balanced before. So I'm going to take a couple of them that we looked at already. So I'm going to take the hydrogen peroxide, going to water plus 2H plus. So I'm going to take 2 equations that we've already done. I'm going to take hydrogen peroxide, going to oxygen, plus 2H plus and 2E minus. And I'm going to take the permanganate one that we also did. So MnO4 minus, 5 electrons, 8 hydrogens, giving us Mn2 plus 4 H2O. Okay, so what we want to do when we're adding these in together is we want to cancel out electrons, just as you would do if you were doing simultaneous equations in maths. Okay, so if you think about it, if you're good at maths and you understand simultaneous equations and you add them together in terms of cancelling out a value, then you'll be pretty good, right? If not, then just try and follow through what I've done anyway. Hopefully you'll find it pretty straightforward. So what we've got here is we've got 2 electrons here and we've got 5 electrons here. Now what we're going to do is find the lowest common multiple of those. Okay. Now lowest common multiple is the number that both of them go into. So the multiples of 2 are 2, 4, 6, 8, 10. The multiples of 5 are 5 and 10. So the lowest number we've got is 10. So in order to get our 5 electrons here to equal 10, we need to multiply everything by 2. 2 5s are 10. Okay. Up here, we need to get our 2 electrons here up to 10, so we multiply by 5. So notice that the number of electrons here is actually the number we have out the front. The number of electrons we have here is the number out the front, so it actually crosses over really nicely. And then what you do is you just add everything on the left-hand side with the right-hand side. Now, because I've got a smaller space here to work with, I'm going to do everything on the left-hand side up the top. So taking into account the number out the front, we've got 5 lots of hydrogen peroxide. We've got nothing else to the left of the arrow there. So then I come down to this one. We've got 2 lots of permanganate, right, 2 chemicals. We've got 10 electrons, all right, and we've got 16 H+. Okay, so that's everything on the left-hand side. On the right-hand side of the arrow, using here, we've got 5 lots of oxygen, 5 lots of O2, we've got 10 lots of H+, okay, and we've got 10 lots of electrons. Okay, and then for the bottom bit, we've got 2 lots of Mn2+, so that gives us 2 lots of Mn2+, and we've got 8 H2O. Okay, so you can see why I've actually tried to go one above the other, but you could do it all in one line, obviously. All right. Now, it's the same as a maths equation, so what you've got on the left-hand side, you can cancel out on the right-hand side. So, obviously, what we've got is we've got 10 electrons here, and we've got 10 electrons here. So the whole point of doing this was that the electrons would cancel out. So they're not going to be part of our overall equation. What we've also got is here we've got 16 hydrogens, here we've got 10 hydrogens. So we can cancel those out, take the 10 away from that. If we take 10 away from this, we're left with 6 hydrogens on that side. Okay? So this is our full half equation now. Our full equation that we've got by adding our 2 half equations together. 5 lots of hydrogen peroxide, 2 lots of permanganate, and 6 lots of H+, gives us 5 lots of oxygen, 2 permanganates, 8 H2O. I'll put the full equation nicely, easily to see down the bottom here now that you can have a look at, so hopefully it makes a bit more sense. But that's how you go through and you add your half equations together to get your overall equation. So we've been through a fair bit in this video. We've been through how to actually write your half equations following these 4 steps. If you can follow those, you'll be fine. Okay? We've been through doing one under alkaline conditions, which is a bit harder, so if you're not getting that, maybe go back and have a look at it. And then finally, we've looked at here adding our 2 half equations together to get an overall equation. All right, if you can master this, then you're really on track to doing really well with electrochemical and electrolytic cells. All right, as always, if you have any questions, thanks guys, and thanks for watching.